Do you recognize this? We call the Earth our home, but did you ever think about what our planet is actually made of? The planet is approximately 4,000 miles from the center to its surface, but what makes up those miles of Earth? The Earth is divided into different layers, just like this cake. Each layer has its own properties and is composed of different materials. Many scientists believe that as the Earth cooled, the heavier materials sank to the center, and the lighter materials rose to the top. To better understand this, let's start our journey inside the Earth.
Let's go!
Okay. First, let's start with the part of the Earth that we live on, the outermost layer called the crust. The crust must be solid, or we'd sink into the Earth's insides. It is made up of rock and loose material. This layer is very thin in comparison to the other layers. The crust is about 5 miles deep beneath the oceans, and about 25 miles thick below the continents. The temperatures of the crust vary, from air temperature on the top to about 1,600 degrees Fahrenheit in the deepest parts of the crust.
Let's start digging.
What is this place?
This is the largest layer of the Earth, the mantle. The mantle is 1,800 miles thick. But before we talk about the mantle, we're going to look at two special parts of this layer that, together with the crust, have unique mechanical properties. The topmost layer is the lithosphere, which is a rigid layer made up of the crust and the upper layer of the mantle. It's typically about 60 miles thick. We can imagine the crust as the shell of the Earth. Actually, we can compare the Earth with a hard-boiled egg, and the lithosphere with its shell. The shell thickness divided by the radius of the egg gives a percentage of 2%. On the other side, the thickness of the lithosphere divided by the Earth radius works out to about 2% too. So the shell is to the egg what the lithosphere is to the Earth. The lithosphere essentially floats atop a semi-liquid layer known as the asthenosphere, which is about 60 miles thick. The material of which the asthenosphere is composed can be described as plastic-like. This allows the solid lithosphere to move around on top of the much weaker asthenosphere. The asthenosphere is a solid, but it is very hot, with properties similar to silly putty. Now that you know about these particular layers, let's get back to the mantle, though the name's not as fun as the other ones. The mantle is made of superheated rock. The temperature of the mantle varies from 1,600 degrees Fahrenheit at the top to about 7,900 degrees Fahrenheit near the bottom. Due to these great temperature differences from the bottom to the top, heat currents are generated that carry heat from the hot inner mantle to the cooler outer mantle, causing movements inside the Earth. Okay, now we're ready to learn about another main layer, the outer core. The outer core is a 1,400 mile thick liquid layer. It's mostly made of iron, so it's really heavy. The temperatures here range from 7,900 degrees Fahrenheit in the outer regions to 11,000 degrees Fahrenheit near the inner core. Without the outer core, life on Earth would be very different. The movement of liquid metals in the outer core creates the Earth's magnetic field, which allows us to use a compass. And here we are in the center of the Earth, the inner core. The inner core is a solid layer with a thickness of 780 miles. It's made of solid iron and nickel.
Oh my gosh, it is really hot down here.
The inner core may have a temperature of up to 13,000 degrees Fahrenheit, which is hotter than the surface of the sun. Many scientists believe it is kept in the solid state because of the extreme pressure from the other layers.
Wait a minute. I'm pretty sure nobody else has come down here, so how do we know so much about the Earth's layers?
Oh, the answer is actually quite simple. It's true we cannot study the Earth using our eyes, but we can use other senses. The most important thing we use to sense the Earth's insides are seismic waves, that are waves of energy caused either by earthquakes or by massive man-made explosions. Timing and strength of seismic waves gives us a picture of the interior of the Earth. Seismic waves gradually bend and change speed as the density of rock changes. Another way to see the inside of the Earth is based on the analysis of rock material brought to the surface from greater depths by volcanic activity. These samples can give hints about the properties of the interior regions.
Awesome! There's so much going on beneath your feet and you don't even realize it. I mean, first we started with the crust, then the mantle, then the outer core and the inner core. Each of these layers is so different. They have different behaviors, different compositions, and don't even forget about the lithosphere and the asthenosphere. But it really is getting hot down here, so I think I'm gonna go back to the surface.
Here we go.
Oh yeah.
I want some crust.
Piso perfecto.
You kids!
Are we having fun yet?
Come on, this was my video.
Count it.